Okay, recording. So let me make this bigger. We can start right away. Okay, so it's we're still adding and subtracting, except that right now the only difference is that we're adding terms that are like, right? So you have to identify them first in order to combine them. Well, that's the only difference, but we're still doing the addition and subtraction that we've been doing. So 3a and 4a, they're both a, so I know it's going to be something a. So imagine, just draw that out. I have 1, 2, 3 a's here, and then I have 1, 2, 3, 4 a's over here. So if I put them together in the same bag, obviously I'm going to have 7 a's. And this is positive, and they're both positive, so no big deal there. So a lot of you had this second problem incorrect. So again, I am going to do, and first of all, I recognize that they're all B's, 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 and B's, so we can add and subtract all of them. But again, let me take these two guys first, right? I'm going to stop right there. So negative 12b plus 6b, and if you ignore the b's for a second, you actually get this, right? The same thing, except there's, next to the coefficient, there's a b. So I know it's going to be something b, right? So if you think about it, negative 6, negative 12 plus 6, right? They're not friends. So there's definitely going to be more negatives left over, so it's negative 6b. Now I'm going to take this guy over here, put a circle, and so it's going to be that negative 6b minus 4b. And I don't see too many of you doing this. You should, unless you're really, really comfortable with this, and you can see this, that this is negative 10b. I'd like you to change this to an addition problem. 6b plus, and this becomes negative 4b. And now you can clearly tell that they're both negatives, and we're going to add those two, right? Because then it's just going to become negative 10b. And that's how you should be doing the problem. Okay, there's no reason to hurry, but rather do it, correctly. So let's circle this guy, and notice that I'm circling the plus 7a squared. So let me write this. Let me just pull it over here. 5a squared plus 7a squared. So those two are done. And then the a's, I have a minus 6a, a plus 3a, so minus 6a and plus 3a, and then a plus 8a, and then I have a minus 2 and plus 7. So these two guys, I can put together. I can combine together. Then it's going to start here and go all the way over here. I can put those three together, and then the minus 2 and plus 7. And that's what I'm going to do. So again, a squared and a squared is the same variable with the same exponent, so I know it's going to be, let's just add them. So I'm going to add the 5 plus 7, and I get 12a squared. That's it. Over here in the middle term, the middle group I should say, let me change color. So it's negative 6a plus 3a. So let's do these two first right here. Negative 6a plus 3a, they're more negatives, so it's going to be negative 3a, right? Then I'm going to add that to plus a squared, plus 8a, sorry. And negative 3 plus 8a is plus 5a, because there's more positives over here. And lastly, negative 2 plus 7, who's going to win? The positives. And I'm going to get plus 5. So this is my final answer. So all that reduces to this. X cubed, x squared, x cubed, x squares, and then there's some x here. So they're all different. So think about PlayStation 3, PlayStation 2, and PlayStation 1. They're all different machines, right? So PlayStation 3, the x cubed, plus 4x cubed. So those two are of the same type, right? So I can put these two side by side. And remember, imagine that this is a stone where you actually wrote 4 plus 4x cubed, and on this stone you wrote 9x cubed. And because there's no sign there, we know that this is positive, right? So I'm moving these two stones side by side. I'm going to take now my x squared. So x squared is this one. So let me write negative 7x squared, and then plus 4x squared, and again, don't forget the sign that precedes it, and then lastly, minus 3x squared. And lastly, what do I have left over? I have a PlayStation 1, or just a minus x. I believe it's a minus x. That's going to be... So you can tell by the colors that I have three different types, right? I have the x cubes, I have the x squares, and the x's. So they're all going to be added separately. So this one is easy. right? So it's going to be something x cubed, and 9 plus 4, they're both positive, is 13. See how simple that is? The reds, it's going to start here at the minus and go all the way up to here. So minus 7 plus 4x squared. So think about this guy and this guy. And who has more? It's the negative, so it's going to be negative 3x squared, right? And then I'm going to do minus 3x squared. And again, like I said before, I don't see too many of you doing this. Well, you should. So it's a subtraction problem, right? So I'm going to do negative 3x squared. I change the subtraction to addition, and I'm going to use the additive inverse, which is negative 3x squared. As a matter of fact, I'm going to bring this guy over here. Now, negative plus a negative, well, they're both negative, so they're friends. So it's going to be just, we add those two together, so we're going to get negative 6x squared. And that minus x in the back does absolutely nothing, because there's no other x's for you to, what do you call, combine this guy with. So this is your final answer. Again, we're just adding and subtracting. Okay, so next, we see a bunch of h's. So some of them are h, regular h, some of them are h squared. So let's put all the h's squared together. So it's this guy, it's this guy. So it's 2h squared plus 2h squared. And then the other ones is, oh, so again, this is a minus 7h. I'm going to change colors. Minus 7h. And then I have a minus h. And then I have a plus 4h. And then a minus 9h, which is this guy in the corner. And finally, I have the minus, is that plus 6 or minus 6? Let me erase that. It's a plus 6. So that's plus 6. The plus 6 is easy because it's not going to do anything. So let's combine these two guys here because they're both h squared. They're both positive, so this is just a 2 plus 2 problem, which is right over here, 4h squared. Now in the reds, I have 1, 2, 3, 4. So again, do it 2 by 2. So start with these. Now, it says negative 7 minus h. There is no number, but remember what I said in class, if you feel more comfortable, how many h's do you see over here? There's only one h, so you can understand that there's only one and not write the 1, or if you can put a 1 there. So it really means negative 7h minus h, and I'm going to change this to an addition, so it's negative 7 plus negative 1h. Negative plus a negative is they're all friends, so it becomes negative 8h. So this, I'm done. Now let me do plus 4h. We don't have to change it because it's already an addition problem. So I have negative 8 here and plus positive 4. Who's going to win? The negatives. So it's going to be y. They're going to win because I got negative 4 more h. And finally minus 9h. So this part over here is the part that I need to do. And I'm going to change it to an addition problem. Negative 4h plus negative 9h. Both negatives, and that becomes negative 13h, right? Because negative 4, negative 9, it's going to be negative 13h. So I did the reds. And in blues, the 6, lonely 6 here, does absolutely nothing. So this is all that, a little bit simplified. 6. So we have AB, AB, A squared B, AB squared, and 5. So remember, like terms have the same variables with the exact same, exponents. So I'm going to use, let's pick on this. Let's use this one. 3a squared. And it doesn't matter where you start. So 3a squared b. Is there anything else that's an a squared b? It has an a with a second power and b. There is. It's this guy right here. And I'm going to put plus 5a squared b. So those two are like terms. They're exactly the same variables with exactly the same, exponents. Then we have this guy over here. It looks the same, but if you notice really closely, it's plus, right? 4ab squared. The square is on the b, so that's a completely different term, okay? And there's nothing else that has an ab to the second power, and then you have these two left over. And these two left over actually are of the same kind. They're both ab's, right? Exactly the same. So I'm going to write at the end plus 4ab minus 6ab. So some of you might ask where I got this plus here from. If you look at this guy here, 4ab, Do we have a sign in front of it? No, we don't. When we don't have a sign, it's implied that it's a positive, right? So let's combine the terms. In blues, this is easy. So it's going to be something a squared b. It's positive 3, positive 5, and that's just an 8. In red, there's nothing to do because that's just one single guy there. And then in black, remember, it starts here, goes all the way here. So it's 4. Actually, I'll bring this guy down. Oops, I can't. So I'm going to bring, so let me just, so I'm going to change that, for example, not for example, so let me write this down, 4ab minus 6ab. Keep the first one the same. I'm going to change the subtraction to addition, and that one's going to be the additive inverse. Who's going to win? Well, positive and negatives. The negatives are going to win, so I'm going to have a negative answer, and the negatives win because there's 2 more, so negative 2ab. So let me attach that here, minus 2ab. So this is my final answer. Number 7. Again, it doesn't get harder, it just gets messier. That's the honest truth. Okay, 7. Ugh. So I'm gonna circle. So it always starts by circling, so I know who I have to deal with. So I'm looking for everybody who's x squared and y squared. X squared. So there's another x squared, y squared here. Again, let me make it a little bit neater. There's another one right here. So all these 3 guys, I move all of them side by side. So I get negative 4x squared y squared plus 3x squared y squared minus 7x squared y squared. So those are the 3. And then there's this guy here. It's a xy squared. So plus 2xy squared. And it's the only one of its type. So I can just, that's it. Change colors. And then I have a 7xy. So I'm going to write plus 7xy. Remember, there's an implicit xy, right? And then there's another xy plus 6xy, which I'm going to sort of sneak in here, plus 6xy. So those are all my like terms next to each other. So let's do these 3 first. So negative 4 and plus 3, well, there's more negatives, so the negatives are going to win. So it's going to be negative 1 x squared y squared, which I'm now going to do with that 7x squared y squared, right? So I did these 2 first. I've got negative 1, and then I'm going to subtract with minus 7x squared y squared. So negative 1 x squared y squared plus negative 7x squared y squared. They're both negatives, so I'm going to get negative 8 squared y squared. In red, there's not much to do, so it's plus 2x y squared. And then in blue, they're both positive, right? This is plus 7, this is plus 6. 7 plus 6 is 13xy. And that's my final answer. Again, I told you, it gets messier. It doesn't get harder. It just gets really, really messier. Number 8. So again, you have to look for the like terms. This one. So I'm going to start with the top. So it's this guy here, the highest. I always start with the highest. So like the exponent, the one that has the highest exponent. So it's that one. This one, they look the same, h4j, and this also looks the same, h4j. So those 3 I'm going to put side by side. So 4h4j plus 13h4j, that looks the same, and minus 17h4j. So h4, sorry, let me put the j next to it. Those 3 are the same. So, because I'm going to run out of room, let's do this separately, okay? So let's do that, and then let's do these 2 first. So I know it's going to be something h4j. They're both positive, makes my life easier. 4 plus 13 is 17. Minus 17h4j. And this one actually, I'm not even going to change to what do you call a subtraction problem, addition problem, because one is positive, the other one. So it's what's 17 minus 17? It becomes 0. And we're not actually going to write this 0h4j. We're just going to write 0, or actually, even better yet, all that disappears. So this disappears because we can even throw it away because it becomes 0, and we don't need to write 0. In red, I'm going to pick another one. So let's do the H3J2. And that's all the three that are left over, right? So again, let me circle. So H3J2, sorry, it's these two. So I'm going to get negative 14 H3J2 plus 15 H3J2. Are they both H3J2? They are. So if I combine them, right, it's an addition. There's negative 14 and 15 and positive 15. Who's going to win? These guys. Why? Because there's just one more. So that's going to be H1H3J2, which honestly, we don't really write the 1 over here. We just write it like that. It's implied. You already know that there's a 1 there, so we don't really write it. So, and then for lucky me, because I'm running out of room, we have this guy over here. And there's nobody here that's an H2J2. So let me change colors. So I'm just going to write that 16H2J2. Remember, we can't just throw it away. So that's what's left over from all that expression. Where am I? Number 8. Like I said, it gets longer, messier, but it's not harder at all. So I'm going to look for everything that's x3y2. So there's an x3y2. Here's another x3y2. That's it. So let me write those two down. 8x3y2 minus 6x3y2. So the answer to this, and again, if I had more room, I wouldn't write it this way. But we're subtracting, right? So this is, I mean, we don't even have to change it to an addition problem because that just says 8 minus 6. And we all know that 8 minus 6 is just 2. So it's going to be 2x3y2. So this and this becomes this. Okay, let's do another one. Change colors. Let's do the x squared y. So it's this one. There's an x squared y. There's another one that looks exactly the same, x squared y. And there's another one. Those three I'm going to combine. I'm going to do it here. Minus 7x squared y plus 2x squared y plus 4x squared y. So this one, they're all addition, so that makes my life much easier. Negative 7 plus 2, it's going to be negative 5, right? There's more negatives between these two, so it's negative x squared y plus 4x squared y. So now I'm going to combine with that one. There's more negatives or positive? Well, there's more negatives. Well, they're not friends, first of all, so they're more negatives. So it's going to be negative 1x squared y. Now that's the answer to the blue ones. And then change colors. There's something that's an x, and there's something that's an x here. Let me put these together. So it's 8x minus 3x, and this one again. This one you don't have to change it to an addition because it's just 8 minus 3, and 8 minus 3 is 5x. And lastly, wow, I get to use purple. I have a plus 4 and a plus 5. Plus 4 and a plus 5. And what's 4 plus 5? That's 9. So I want to write everything together. So I'm going to write everything together in orange. I don't know. I think I'm going to write it here. So the first thing is 2x squared, y squared, which is this guy. Check. The second one is this one. And I'm going to write minus 1x squared y. And then this guy, 5x, what kind of 5x is that? Positive and negative? It's a positive, right? So I'm going to write plus 5x. And this 9, what kind of 9 is that? It's a positive, so I'm going to write plus 9. So I combine all of them, and that's my final answer. 10, hopefully it's not as long. So 10, let's start with R3t. So let's look for something that says R3t. R to the third power and t. Is there anything else? No. So that one is just going to be, I'll start writing here. 3R3t. Nobody else. So there's nobody to combine with. Actually, I'm going to write it over here. And then to the second power, I have, change colors, this guy over here, plus 5RT squared. Is there anything that says RT squared? There is right here. Plus 6RT squared. There's nobody else. Change colors. How about RT? This is just RT with no exponent, so minus 6RT plus 4RT. They're both RTs. And finally, way at the corner, you see a +5, and that +5 obviously does nothing. So I don't have to worry about this guy, and I don't have to worry about this guy, but I have to worry about these two. So from here, it goes all the way to here. It's an RT squared, right? So let's focus on the numbers. It's +5 and +6, and 5 plus 6 is 11. So that becomes 11 RT squared. So let me write this down. Plus 11 RT squared. In black, I have -6 plus 4. So something RT, -6 plus 4. There's more negatives. How many more negatives? 2 more. So it's -2 RT. So I'm going to put it over here. And that +5 there in orange, there's nobody, the 5, poor guy, has nobody to combine with. And that ends up being my answer. Where am I? 11. So again, I like to start with my highest ones. And 8x to the 4th power. Is there anything x 4 power? Yeah, there is right here. So I'll put those two side by side. Let's talk about 3rd power. There's one here. -7x to the 3rd power. Actually, there's no one else. That's it. But there is a y here, so there's a +2y cubed +2y to the 3rd power. And if anything y to the 3rd power, there is one right here. So +3y to the 3rd power. And the leftover, we have these guys here. -7xy, and then +12xy. So I guess by colors it comes out really nice. So let's do the blue ones. 8 plus 4x, they're both positive, they're both friends, so that I'm going to write right here. 12x to the 4th power. 8 plus 4 is 12, and then the x4 just stays. In red, this guy has nothing to do. In purple, I combine these two. Right, they're both y cubed, so it's 2 plus 3, which is going to give us 5y cubed. And in orange, it's going to be something xy, right? So it's -7 plus 12. There's more positives, so how many more? 5 more. And that's going to be plus 5xy. So all that becomes that. 13. I am looking for anything that has an a to the 3rd power and a b. So 3a, 3b. Is there anything like that? Yes, there is right here. If you look at the a's, they're exactly the same. So it's -7a, 3b. And finally, there's one more. Plus 10a, 3b. They're all exactly the same. Change colors. I have something that says a squared, b squared, so it's plus 4a to the 2nd power, b to the 2nd power. Is there anything that's similar? Yes, there is one right here. Minus 5a 2nd power, b to the 2nd power. And finally, the last guy over here, put in blue, I think that says minus. And let me just erase it. Does that say minus? No, it says plus. It says plus 2ab, which is this guy right here. You don't have to worry about the blue. The red, you have 2 terms to combine, and the orange, you have 3. So let's do the orange. Well, again, we're doing these two guys first, right? So always do it slowly. So if you change that to a, what do you call, addition problem, it becomes 3a, 3b. That stays. The subtraction becomes addition, and that 7 becomes -7a, 3b. It's a positive plus a negative, so there's more negatives. How many more? -4, so it's -4, a3b. Now we're going to unite this guy over here, plus 10, a3b. It's a negative plus a positive. Who's going to win? The positives. Why? Because there's more. So it's going to be 6, so it's 6, a3b. So all that orange becomes 6, a3b. In reds, we have a plus 4 and a minus. So again, if you want to change it, so that stays. The subtraction becomes addition, and we're going to use the additive inverse, so it's -5a squared, b squared. I think it's easier for you to see it that way. More negatives, are they friends or not? Not friends. It's more positive or more negatives? More negative. So these guys are going to win. So I know it's going to be a negative answer. And they have how many more? They have one more. So -1 because they have one more. So it's 1a squared, b squared. And finally, plus 2ab. Okay. So again, like I said, the more organized you are, if you want to use highlighters, I think that's not a bad idea to circle, but keep them very organized. It will be to your advantage because that's the only thing that might get in the way. So these are all y, so this is sort of simpler. 5y to the fifth power. Is there anything y5? Nope. Change colors. Let's do anything with y4. There's one here. Change colors. That is plus 4y to the fourth power. Is any out? No, no more y4. So those two we have nothing to worry about. Change colors. Y to the third power, there's one guy right here. Plus 3y cubed. That's to the third power. Anything to the third power? Yeah, there's one over here. Minus 7y cubed. Minus 6y cubed. So those are all the y's to the third power. And change colors. Where am I going to go? Black. Minus 6y squared, right? Because that's a different type of y. And finally, orange. I have the plus 8 and plus 11. Plus 8 and plus 11. So again, imagine these were all stones, and I asked you to move all these stones by color, right? So all the light colors next to each other, and that's exactly what you would have. You can combine some of these guys, right? So orange, purple, let's start with the purple. 5y cubed, 5y to the fifth power. That's the only one, nothing to do. This one, again, nothing to combine, so we're just going to write it down. In blue, we have some work to do, so we got these two guys that we want to focus on right now. So I'm going to write 3y cubed, change the subtraction to addition, and change the 7 to negative 7y cubed. Who's going to win? There are more negatives, so how many more? Negative 4, which I'm going to now combine with a negative minus 6y cubed. Keep, change addition, subtraction to addition, and the 6 becomes negative 6. They're both negatives, they're both friends, right? So it's 4 and 6. So if I have a group of 4 negatives and a group of 6 negatives, I'm just going to have 10. So all that becomes negative 10y cubed. And in orange, I have a positive 8, but a positive 11, so there's nothing to really think about there. It's just 19. So this is your final answer. Hopefully you're getting the hang of it. Okay. 14. So we're not going to do, I only asked you to do 14 and 15, up to 15 in the back, right? So you don't have to worry about that. So we'll eventually, tomorrow, hopefully, we'll do that. 14, c squared d, so actually, yeah. You know what, let me keep this. Let me pick the d3. I'm going to take the highest exponents first. So I have 6c d to the third power minus 4c d to the third. Those two are the same. Now I'm going to do anything that has c squared d squared, c2 d2. Not that one, but this one. This is a c2 d2, and this is a c2 d2. So let me put all those side by side. Plus 10 c2 d2 plus 5c2 d2, and then plus 3c d2. C2D2. And then we got this guy left over, and this guy's a little bit different. Minus 3C2D. Notice that the D has no exponent, so he is different. Let's do the orange. This one's easy. 6 minus 4 is just 2CD3, right? We don't even have to change it, right? Because that one we can do it. The blues. Well, it's 10 plus 5. They're all, thankfully, they're all positive, positive, positive. So this is 10 plus 5 plus 3. 10 plus 5 is 15. 15 plus 3 is 18. So that all becomes 18. So change colors. 18. And 18 of what? 18 of the C2s, D2s. So plus 18 C2s, D2s. And finally, the last one, minus 3 C2, D. Oops. Right, C2. Okay, so that's my answer to that. And we have one more over here. And again, let's choose the x's. Let me do the x's. X to the third power. So 4x to the third power. Find anything that's x3, x3, x3. Oh, there's one right here. there anything else? We have y3. Yeah, we have a y3. So I'm going to change color. I'm going to take care of all the ones that are higher exponents. Minus 25y cubed. Is there anything else? It's a y. Yeah, there's one right here. Sorry, I forgot that one. And then we have purple. It's going to be x squared y. So plus 3x to the second power y. Is there anything else that says x to the power y? No, these two are different. Okay, careful. And then orange, and you can tell, I'm going to show you why these are different. This one says plus 2x. The y is to the second power, so it's different. Okay, and then we have this guy over here, plus 3x y to the second power. Let's do the blues. 4, they're both positive, positive 4, positive 5, so that's just 4 plus 5, which is 9x cubed. Let's do the ones in red. In this one I actually, only to help us see it better, I would change it to an addition problem. So it's negative 25 y cubed, subtraction becomes addition, and that 6 becomes negative 6. So they're both negatives, it becomes negative 31 y cubed. So negative 31 y cubed. Much easier to see it when you change to addition for some problems. In purple, there's nothing to do. And then in orange, I can combine, thankfully, again, this is addition and addition. They're both positive, so 2 plus 3 is just 5x y squared. Again, nothing you've never done. Don't make this harder than it is, because it's not. You do have to be careful. You do have to put the like terms next to each other. You have to recognize who the like terms are. But at the end of the day, it's just addition and subtraction. So there are quite a couple of steps that you have to do before you combine them. But that's about it. So, I mean, we had some... So write an expression for the perimeter. So remember what perimeter is. To find the perimeter of a shape, we add all the sides. So let's add them. So it's this guy plus this guy. I'm going to add that. I'm going to add 6x minus 17. Oops. Plus 6x minus 17. So these are all the sides added together. So I am going to circle all the x's. So it's going to be this guy, this guy, this guy, and this guy. So I'm going to put all of them next to each other. And then I'm going to put everything. This is a plus 5, plus 2, and minus 17. So those are going to plus 5, plus 2, minus 17. All my numbers together, all my, x's are on one side. So this is all addition, so it makes life very easy. So again, this one, make sure you put a 1 in there to make life easier. So it's 1 plus 2, which is 3, 3 plus 3, which is 6, and 6 plus 6, which is 12. So I have 12 x's in total. Red, well, this says 5 plus 2. 5 plus 2 is 7, so that's easy. And then minus 17. So it's 7 plus negative 17, and that's going to give me negative 10. So final answer, 12x minus 10. I combine all the blues, I got 12x. I combine all the reds, 5 plus 2 minus 17, and I got negative 10. So the perimeter of this particular shape right now is in this format. And in a test, they usually say, hey, now that you have this, figure out what its numerical value. Let's say x was 3. Well, you would come in here and you would substitute. I'm just adding to this question. So I would put 12, and instead of x, I would put 3 minus 10. 12 times 3 is 36 minus 10, and 36 minus 10 is just 26. So the perimeter would be 26. Again, if they told you that x was 3, you could do that. Okay? That's how I would give. Here's on the rectangle, I want the perimeter again. So if this is 3x, this means this is 3x. If that's the 6x plus 5, this is 6x plus 5. Well, perimeter means add all the sides, so let's do that. 6x plus 5 plus 6x plus 5 plus 3x plus 3x. This one's nice and easy because it's all addition. But nevertheless, I'm going to circle all my x's. So plus 6x, plus 3x, and plus 3x. And I'm going to put them side by side. So perimeter equals 6x plus 6x plus 3x plus 3x. And then the plus 5 and the plus 5 use a different shape. I'm going to put them at the end. So all my numbers are next to numbers. And all my terms with variables, in this particular case the x, are next to each other. So again, because this is addition and there are no negatives, it becomes very simple. 6 plus 6 is 12, plus 3 is something, 15, plus 3 is 18. So I have 18x in total. Positive 5 plus 5 is just 10. And again, they could have given you the x as a value and you plug it in. So the perimeter right now, it's that. It's a hexagon, so it has 1, 2, 3, 4, 5. How many sides? 6 sides. So this is 4x, that's 4x, that's 4x, that's 4x, and that's 4x. We want a perimeter. So now the perimeter, all the sides together, we can take a shortcut here. Instead of writing 4x plus 4x, whatever, 4x plus 4x plus 4x, whatever. How many 4x's do we have? 1, 2, 3, 4, 5, 6. So I'm going to write 6 times 4x. Now multiplication is repeated addition, right? Instead of adding 4x plus 4x 6 times, I can just multiply. So what's my total? 24x. You could have added, be my guest, if you want to write 4x 6 times, or you can just realize that it's the same as multiplying by 6. That's fine too. 24. Did I ask you to do 24? Uh-oh. Not too sure. All right, so I'm going to do 24 because I don't remember. So here's a rectangle. And it says that the perimeter of the rectangle is a length that is 5 inches longer than its width. Well, notice that they're talking about the length. Did they say anything about the width? No, so we know, or we're going to assume that the width is just the width. The length here says the length. So let's again translate that right into algebraic expression. 5, it's 5 inches longer. Longer means addition than the width. So the length is whatever the width is plus 5. So I am going to take this. All right, so the length is whatever the width is plus 5. So if that's 5 plus w, guess what? This is 5 plus w. Now I can do the perimeter. 5 plus w plus 5 plus w plus w plus w. Combining like terms is this guy with this guy with this guy with this guy. And I'm just going to write it again. And then plus 5 plus 5. So if you combine, stop. If you combine all the like terms, you have w plus w plus w plus w. How many w's are there? Well, it's 4 w's, right? Oh, I forgot a 5 here. And then you had to add the 5 plus 5, and that gives you 10. So the perimeter of this rectangle for number 24 will be expressed in this manner. Since I'm at it, let me do 25, although I don't think I gave it to you guys. Write the expression perimeter of a rectangle with the length. Again, here is the perimeter, and it's talking about the length. So they say the length is blah, 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 blah. What about the width? Did they say anything about the width? No, so let's just write that the width is the width. So this is the width right now. It's represented by W. So the length is 4 centimeters longer. So 4 centimeters long would be 4 plus then 3 times the width. And I'm going to write like that. So we have the length in terms of W. So whatever the width is, it's going to be, so to find the length, if we know the width, all we got to do is multiply the width times 3 plus 4 and we get the length. So, and again, if this is 4 plus 3w, that means that this is 4 plus 3w. I don't need that dot there, but just to let you know. Again, perimeter, combine all the like terms, w, plus combine all the sides, plus 4 plus 3w. Combine this guy with this guy with this guy with this guy. Write it next to each other. W plus 3w plus 3w. And then I'm going to just make a square out of this. Plus 4 and another rectangle, sorry, not a square. So the perimeter is expressed algebraically here. It's going to be w plus w is 2 w's, plus 3 w's is 5 w's, plus another 3 w's is 8 w's. And then 4 plus 4 is plus 8. So your perimeter of that rectangle is 8w plus 8. And we don't know what w is right now, but that's okay. So that was your very simple homework.